Hi, today we are here to talk about our project, Airbnb Price Prediction Model. We have 4 team members together to work on this project: Bakako, Anel, Dantas, and myself, Junjun. The slide will start from introduction, objective and research question, process flow, methodologies, the explanation of 2 datasets, data cleaning and preparation, model deployment and result, and the final gonna be conclusion and future work. From our researching, we find that Airbnb hosts need guidance when they're choosing a price range and posting the property online. Many people will check their neighbors' fees and choose similar prices, and many people cannot decide on price list because they don't know how much similar booking costs be. Sometimes the host set price on external motivations that are not related to market price or value. For example, a host tries to put up a rental price to cover their mortgage rate. Therefore, it's distorting the price list and making it harder for the neighbors and competitors to set a price accurately as well. Our solution for this project is try to using data mining methodologies, find the main factors which influencing rental price per night on Airbnb. The purpose and benefit for this project is provide an accurate model for price prediction to help hosts to set their price accurately when they want to post up their house for online rental market. Our main objective is to find main determinants of price. The primary research question is what are the main factors that influencing Airbnb price per night. Our secondary objective is try to compare need-based and neural network model prediction accuracy on price, low or high.
This is our process flow. We used CRISP-DM for research approach, and we have 2 data sets, and we did a cleaning, missing check and data cleaning, and after clean the data, we merge them and reduce the observation number, and we did it on the sentiment analysis to get score on the second data and aggregate and get average score, and then join back again to the first data, and we got the final data. Once we get final data, we did the data distribution check and followed by normality test, outlier remover, and correlation check. After we got that, we did multilinear regression test, and then from that attribute, we set the train data, test data 80%, 20%, and naive bias test and neural network, and then get the result, and we had a conclusion and presentation.
The data we used for the research is the result of the combination of 2 datasets. One dataset from Airbnb with various host and property attributes, and the second dataset consists of online comments and reviews from Airbnb website too. The datasets were joined to create a final dataset. So the data was cleaned, the variables with the high percentage of missing values were removed, and we inputted missing values with random forest. For the analysis itself, we have used 3 algorithms. First, a multiple linear regression for price prediction and answering the results question. And then we used naive Bayes and neural network for classification. Now Bakako will present the 2 datasets in more details.
We have 2 datasets. The first dataset has 106 attributes and nearly 10,000 observations. The first dataset has the information of accommodation such as price, accommodation details, and host information and communication rate. And the second dataset has 6 attributes and over 340 observations, and they have review comments per accommodation.
In the first dataset, we checked for missing values and we removed attributes containing 17% or more of missing values. Therefore, 21 attributes were removed. Then the attributes without added value were also removed, for example, those repeating an identical value for 100% of observations. The approach to impute missing values is random forest, as mentioned before. The other part of cleaning was to remove special characters. We also checked the distribution of numeric data to identify outliers. We removed those outliers and checked again the distribution after. The second dataset of reviews was quicker and easier to clean. There were only 97 observations that were incomplete, so given this low number, we decided to remove these observations entirely. To finish, we carried out a text mining of reviews to compute a sentiment score for each observation.
In the following section, we will present our models and their results. Here we perform correlation plots to see the correlation between all of our variables. Then we removed variables that were highly correlated. In such cases, when there were two or more variables that were highly correlated, we would remove one or two or more of them, which, if removed, would have lowest impact on our R-square of the regression. After removing all highly correlated variables in such manner, we ended up having adjusted R-square of approximately 58%. This means that 58% of the variance is explained by our multiple regression model. In this slide, we can see the output of the regression with variable beta coefficients and statistical significance tests. The variables we chose to include into our regression and later on use the same variables for naive Bayes and neural network are the 14 variables that have p significance level of 1% or less. These variables are the ones that have one or more stars on the right hand side of the screen. Our multiple linear regression takes the final form that is seen on the screen now. Before I start explanation of the model output, I want to highlight that every explanation of the variable is assumed to be presented in a vacuum, meaning it is assumed that the point unit change increase in a variable affects the price in specified beta coefficient while holding all other things equal. To start off, the intercept of the model is 24.52, which means that if all other inputs are 0, the price would be 24.52 by default. For each point increase in host response time, the price is expected to decrease by 2.4 per unit increase. Looking at how this variable is encoded, this means that the faster the host responds, the lower the expected price is. The host total listing count influences the price positively by 0.14 points for each point increase. This means that based on our data, it can increase the price by up to 14, as maximum listing count in dataset is 100. We can also see that host having a picture has a very strong positive effect of 36.28. Room type has been found to have negative effect of minus 48.03 for each point increase. In this case, this indicates that a decrease in room privacy going from entire apartment home to a shared room would decrease the price by up to 144 points. Number of bedrooms similarly was found to have a significant positive effect on the price of 20.5 for each bedroom, up to a maximum of 10 bedrooms. Similarly, number of beds influence price positively by 5.75 points for each unit increase. The price for each extra person has been found to have a negative impact of 0.17 for each unit increase. This can go up to 300 units. Next, we found that some of the review variables have positive effect and some have negative. The ones with positive effect are exhibited by review score rating, cleanliness score, and location score. Respectively, the impact of them is 0.78, 2.24, and 11.6 per point increase. This means that the higher the average review score, cleanliness, and location score ratings are, the higher the price. On the other hand, the variables which influence the price negatively are review score value and number of reviews per month, which decrease the expected price by 10.82 and 2.96 per point increase, respectively. We have also found that an option to instantly book room for the stay is expected to increase the price by 2.8. And lastly, we found that stricter cancellation policy is associated with higher expected price by 3 unit increase for each level of strictness in cancellation policy. For naive Bayesian neural network, we used for the 14 variables which we found as significant for multiple linear regression, meaning the same variables were used for both of these classification models as were used for multiple regression model. Here we compute naive Bayesian neural network classification rates and then compare the classification prediction accuracy on price group, whether it's below or above average price. Lastly, we compare the classification rates against real distribution of price and decide which model is more accurate. From the naive Bayes output, we can see that it classifies 67.6% as being below average price and 32.4% as above average price groups. Below, we can see charts for probability distributions for each attributes against price that we used in classification. 100% stacked charts represent factor data, and line charts represent numeric data. As we can see from these charts, the distribution is not always optimal, and in some cases may introduce some bias. However, after completing the classification, and as you will later see in the results section, these distributions provide a very small bias that did not influence the outcome at all, because both models predicted the classification very accurately. Next, we perform neural network with the same 14 attributes as for multiple linear regression and naive Bayes. Our neural network has 2 hidden layers, which is the second and third, the 2 layers in the middle. And it also has 2 outputs, yes and no, for below or above average price. On the left hand side, we can see the weights for each layer of neural network, and on the right hand side at the top we provide an example output for the top 16 observations. Here we can see that in most cases neural network takes very extreme prediction stance. For example, for the topmost observation, it states that there is 98% probability that it belongs to the below average price category. On the bottom right, we provide the final output of a model showing that neural network classifies 69% of observations as below average price and 31% as above average price. Moving on to conclusions, I just want to remind that our multiple linear regression model captures 58% of variance explained as measured by our adjusted R-square. Here we can see on the left hand side all the factors that statistically significantly influence Airbnb price per night. Of these, the ones with strongest positive effect are number of bedrooms and beds, location, and review value score, and also host having a profile picture. The strongest negative effect is seen from host response time, room type, and price for extra person. From these findings, we can conclude that what people value the most, as predicted by our model, is privacy, as indicated by desire for many bedrooms and beds, and room type, with significant preference for renting out the whole apartment as opposed to shared bedroom. And convenience, as indicated by location score and unwillingness to pay much for additional extra person. For naive Bayes and neural network conclusions, these are a little bit different. The two classification models that were used are on the opposite spectrums, meaning naive Bayes is a robust yet very simple model, while neural network represents advanced and very sophisticated model. However, as we can see here, obtained results show that neural network is a bit more accurate than naive Bayes. Having said that, naive Bayes is not far behind and seems to work very well right out of the box. Overall, both classification models are very accurate and show similar classification outcomes as can be seen on the screen left-hand side.
We suggest some future work to better assist hosts and provide them with comprehensive information for setting up prices on Airbnb. So an analysis of locations of accommodation and the impact on prices would be relevant. The data is available in the dataset, so this type of analysis would be possible. And we could create a locational pricing map. We could also add a time dimension in order to capture how prices vary with seasonality during the year and over time given external conditions such as political, economical, and social demographic factors. Another idea for future work is to research additional conditions and, for example, cross a calendar of events with the location and dates of room bookings. Lastly, for Airbnb to be proactive with price recommendations, we suggest to create an alarm to give host pricing recommendations during the time the accommodation offer is up on the platform. This is the end of our presentation of Airbnb price prediction model. Thank you for your time.